What a beautiful day in the robotics neighborhood. I've got my toolkit here. What we're going to do is learn some basic skills about how to build a robot. So by the time we're done today, you'll know what you need to do things like make a circuit and hack a robot and make a toy into something really cool. Now, I want to show you a little bit what I have in my toolkit. You can be very simple with what you need. Let's start off with safety. I carry my wraparound safety glasses in a plastic bag so I don't scrape up the lenses here. I have safety glasses right here, polycarbonate lenses, so I'm not going to wear these, but I recommend to all of you that you have some kind of safety protection here. Most important instrument for working with electrical circuits is a multimeter, and it's got some cables, and we'll talk about how to use that in a second. I've got a flashlight here, which often comes in handy. Miniature screwdriver set, which can also be really cool. We're not going to need it today. I'm a nut about keeping cabling and cords together, so I like to carry around a set of twist ties. Hot glue gun. Stuff I've already got out includes a small pair of scissors and locking forceps. These are snips that are going to help us cut wire. I'm going to bring those out right now. And a pair of pliers. I love locking pliers. They can be very handy. And a convertible screwdriver, which allows you to flip from a Phillips head to a standard head screw. Now, what else do I have here? Let's see. Tools of the trade if you're going to be a maker. Again, not a lot of stuff. I've got solid core wire, and I've got stranded wire. I've got electric tape, which is very important because it insulates when we are trying to make circuits work. And I've got this stuff called rosin core solder, and the rosin in there helps that metal flow onto the wires and things that you're heating up and trying to essentially weld together here. It's also lead-free, and that's important because you generate fumes when you use solder. All right, so the first thing we're going to learn how to do is to strip wire. So before we do that, though, because we're going to be using the soldering iron, let me plug it in here, and I always unplug the soldering iron when I'm done, even though I've got an on and off switch, just for safety. So there's never any doubt in my mind that I've left this on and it could fall off and cause something to burn. So we're going to be very careful with that. All right, first thing, I'm taking solid core wire here, which is very useful if the thing that you're wiring together is not actually going to move a lot. If it's going to wiggle a lot, the solid core wire will break, and then you need to use stranded wire. I'm actually going to cut the tip of that off. So here's what stripping wire looks like. I'm removing that red part, which is actually insulation. And that insulation removal is going to allow us to make a connection with another piece of wire. So let me just snip this off here and talk to you about what I just did there, because I did it very quickly. It's like, oh, okay, that looks easy. Well, guess what? I can, if I place full pressure on this pair of snips, I just cut the wire. There's no special thing on these snips that is cut to make sure that I'm not going to cut that wire. You can actually buy wire strippers, but then you have to make sure you match the wire size. It's really a mess. So I recommend just getting a pair of cheap snips like this and learn how to do the following, which is you don't press down all the way when you're stripping the wire. Some people like to rotate the wire and sort of cut that insulation around in a circle. And then you grab on with, if you're right-handed, your left hand, and then you're going to slide off that insulation without pressing down anymore. And it's okay if you miss, go back there and there you go. You've got a hollow piece of insulation that you've left because you've now just pulled it off that wire. So that's what you need to do for wire to get it stripped. Now I'm actually going to take a piece of stranded wire to show you what that looks like, and then we're going to join these guys together. So here's stranded wire. It's copper inside. Stranded wire is also harder to solder because the solder doesn't take to it as well as the solid core wire does. And before we even solder, though, guess what we're going to do? We're going to just twist wire together. You do not need to solder if you need to make something or hack something. You can twist wire together, as you see here on my board. I've just twisted that together. I usually like to put a little piece of electrical tape to hold that together. You can actually, I like to cut electrical tape. Some people pull it like this, but then the end bunches up. That drives me nuts. I'm going to get out my pair of scissors and cut myself a little piece of electrical tape. You can do it however you want to do. And all these things are very stylistic, so don't worry if you have your own style, because you will. All right, so I got this twisted together, and I'm just going to put a little piece of this electrical tape on the bare ends that I just stripped and then twisted together. I'm doing that for two reasons. That's going to help it stay put and not pull apart. And also, if I happen to touch the bare metal contacts there to something else electrical, I could short it out if this were an electrified circuit. So I have to strip the other end of this wire, which I see I've missed again, pushing down only partially, pulling out, and I'm going to twist the strands together to give them some coherency. All right, now we get to learn how to use the multimeter. These are very inexpensive, and you should go to the hardware store and buy one. You need to make sure that your multimeter comes with cables. Here we go again with the twist ties. Okay, so there should be a red and black test cable. Test leads, they're called. And I'm going to untangle them here and then plug them in. The red goes into, there's usually a couple spots for the red, and measuring voltage. The COM means common or black for ground also. So I've got my black one in and my red one in. Now, the best thing about multimeters, and the reason they're called multi, is they measure a bunch of different things. They measure direct current voltage over here. They measure alternating current voltage here, which we're not going to get into. When we build electronics, we're working in the DC world, but that's nice in case you need to measure the what's coming out of the wall socket. Here's direct current amperage, DCA, over here. This is actually a very important area right over here with this ohm sign, which is where we're measuring resistance. This little thing over here is how you measure a transistor and how your transistor is doing, and we've got some stuff over here with temperature. Now, there's something going on here which we're going to use, and that's this little speaker. This speaker is measuring what's called continuity, and that's, we want to know if we've got a good connection, continuity, when we wire something together. So if I touch these two leads together, you can hear, I hope, beep. That's the signal that I've got continuity. Well, of course I have continuity because I've touched these leads together. Here's where we test our twisted wires. Now, these alligator clips I'm going to slide on because they're going to help me hold on to the end of those test leads. And I'm going to clip one end and clip the other. You can hear right away that we've made a good connection just by twisting. Perfect. Now I'm going to take these apart and we're going to do some soldering. So that's proving to you, I hope, that twisting together is going to work fine. Now, the soldering iron. Again, you can burn yourself, so you need to be very careful. And you have to have this soldering iron. Never leave it down on the table. You'll melt your wire. You'll do something bad. Always put it back in the holder. Now, I can actually feel that it's hot, so I don't have to test it with my hand or anything crazy like that. And I want to show you in the soldering iron holder, there's a little sponge which I've dampened. It doesn't need to be wet. The reason I've dampened it is I'm going to take this hot soldering iron and just brush it gently onto that damp sponge. And that's going to help clean the tip. The next thing I do to prepare it for use is I'm going to take the solder and I'm going to do what's called tinning. Okay, so I'm just going to put a little bit of solder, and you can see it melt there, producing some smoke, which you should not breathe. So you want to work in a well-ventilated area. Some people build a little fan as one of their first projects here. And you can see there's a little bit of metal that's been melted and put on the tip. I'm going to rub that off again. So now I've got a nice little bit of solder on the tip of my soldering iron. Okay, so there's the solder. Now, I'm going to put this back in the holder for a second and move this whole thing a little closer. I've got on here some alligator clips, which some people call magic hands. Turns out, most of the time when you're soldering, you need 3 hands. You're holding 2 wires, or a wire and a soldering iron, and then you have to get the solder in there. And that's where these magic hands come into play. So I'm going to go back and twist these wires together like we did before. I had removed them when I pulled the tape apart. And I am going to clip them into the alligator clip right there. And then what I like to do is actually leave the solder on the table, unwind it, and we're going to melt metal to make an even better connection here. Now, here's the crazy counterintuitive thing about soldering. You actually don't want to melt the solder directly. You want to heat up your wires and let the wires melt the solder. Okay? Now, the reason for doing this is you get what's called a cold bond if you don't do this. The metal cannot be at the right temperature if it moves right into the cold metal. So I've heated up those wires. Now that solder isn't flowing, and that happens when you have lead-free solder. It doesn't flow as easily because its melting point is higher. So I'm going to get it started on the soldering iron, but then it should flow now. As you can see, there we go. Yeah, the wires are hot enough. And so the sign of a good solder is a bright, shiny silver finish. If it's sort of a matte finish, then you've got this cold solder that you've done. And that's probably not going to be a great image. I forgot to wipe off the tip of my soldering iron. Make sure the cord's out of the way here. Okay, release the wire. Release the hounds. And so here's that solder. It looks kind of ugly, but let's see if it's any good. We've got the multi-tester. We've got it on continuity. Alligator clip. And you can hear right away, perfect. So that's really annoying. So we'll stop with our little perfect thing here. Now, that's the last of the soldering we're going to do because I've pre-cut and pre-soldered a bunch of stuff. I want to get into building circuits with you. All right, let's start with the idea of what an electrical circuit is very quickly. In an electrical circuit, you need an energy supply. So we have a battery here. And you need something that is offering resistance to that circuit. And so the something I've got here is a DC motor. And I've got the DC motor hooked up, as you can see here. And let me point out, I have soldered a lead, red for positive, black for negative always, these leads onto the motor. And they go to a little cap into which a 9-volt battery fits. So a circuit is anything that connects up the negative and the positive poles of a battery. We could take the wire that we just soldered and connect up those two leads. What would immediately happen is, because there's so little resistance in a wire, that the battery would start to heat up. This is a bad idea. Don't do it. So never connect a wire between two poles of a battery. You will create a problem. We always want something that is slowing down the transfer of electrons from the positive to the negative pole. So making a circuit is all about using those electrons to do work for you. And there's nothing simpler this way than a light bulb, or I like to use motors because it's an actuator. And so just like in robotics, to make this work is touch it with this direct current motor, and we get those electrons flowing from positive to negative poles and doing electrical work for us. All right, so I'm going to put that away and grab out of this little bin here 2 resistors and 2 wires that I've pre-cut. We're going to build a circuit that's called a voltage divider. And voltage dividers show up everywhere in electronic circuits. They're very handy. We're going to use them in the Tadro circuit that I'm going to show you and a light sensing circuit. I've got here 2 resistors, fixed resistors, that are equivalent in their resistance. I've also got 3 different wires that we'll talk about in just a second. Now, in the multimeter, what I'm actually going to do here is switch it from measuring continuity. Well, just for fun, let's do that real quick to show you that it's going to sing. Okay. Actually, it doesn't sing. There's enough resistance there that it's not registering that as a clear shot through. So now I'm going to swing this around to measure resistance. And I've got connected here. What's actually happening is the multimeter is running current through this and measuring the resistance to running that current. And what I've got here is a resistance of 9.90 watt. Well, I've set it at 20 kiloohms, so that's about 10 kiloohms resistance. What we're doing with a voltage divider is using the fact that resistance is a way to relate the current, how much current is flowing, to how much voltage we have to actually drop the current and hence drop the voltage. So all I'm going to do here is some twisting. I'm going to take the two resistors and a red wire, twist them together, and then I'm going to split those resistors up here, and to one resistor I'm going to attach a black wire. Black is always going to signal for us the ground or the common, and then the positive side here, twist that together. And what we're going to do is use this battery and show you what this does here. All right, so the circuit is very simple. You can see I've joined the two resistors together. I've pulled off what's essentially the positive lead from it. So here's where we're dividing that voltage. I'm going to remove just for a second these alligator clips. Now I need to turn this to voltage. So DC volts, the multimeter, it's reading 0. I'm going to touch the 9-volt battery, and I'm reading about 8 volts here. So this battery's been used and loved. Okay, this also tells me, by the way, if I were to flip it here and get a negative 8 volts, it just means I have the leads switched. Here's the positive pole of the 9-volt battery, and here's the negative pole. No big deal. It's still the same voltage. We've just switched those leads. So we've got 8 volts coming out of here. Now, I'm going to attach, just using my fingers here, there's no danger. This is not high voltage situation. I'm going to attach, once again, these clips, because they're going to help me with my problem of not having enough hands. And watch what happens. So that was 8 volts, and I'm now going to take the black and put it on the black right here. That's our common. And then here's where our new output is coming. I'm going to get this out of the way. And we clip it, and what happens? All right, very cool. We've just dropped the voltage to 4 by using 2 different resistors of equal strength, equal resistance in ohms. We have cut in half that voltage. So that's about as simple a circuit as you can get that does something useful, like change the way that the electricity is flowing in its system. Okay? Now, what's really helpful here, and I don't have time to get into, is Ohm's law. Voltage equals the product of current and resistance. If you want to look that up for a resistor, you may. Now look what happened. I wound those together, and it's already fallen apart. So we're going to set that aside here. Now, using that idea of a voltage divider, we're going to do something useful for the Tadro robot. Now, I don't know if you remember the Tadro robot here, but it had a single eye spot, a single tail output. I'm just going to turn this on. So this was a great connection between a sensor and an actuator. Now, if we look at the tail, it's about to start flapping. And we have the light sensor over here. If I cover it up, you can see it adjusts the way it's turning. So we have this neat, intelligent circuit with an Arduino in between. So when we built Tadro, I very quickly twisted together some wires for you, and we're going to do a little bit better job today on this. So what I've assembled here is, it's going to look eerily similar to what we just did. I've got a resistor and some wires that I've pre-cut. So let me explain what's going on here. So you've seen a voltage divider where we took the 2 resistors and we twisted them together, right? And then we had our input wires and our output wires. Now, what I've done here is, before we started, I went and diagrammed what the circuit looks like that I wanted in Tadro. So I have our 2 resistors here, and I then have to convert a circuit diagram. You can look these up. They're all over the place. They're easily found, a circuit diagram. But then you have to convert the circuit diagram into really what is your wiring diagram and how you're going to cut the wires, because circuit diagrams can be a little abstract. They're meant to talk about the electrical current flow and not necessarily how you're going to wire. So I've got my wiring diagram here, and I see, okay, I've got to twist together my fixed resistor here, and I want a positive output. Now I'm dealing with solid core for a reason I'll explain in just a second. Okay, so I've got my solid core. This is going to be my output, the middle of that voltage divider. And then I've got, let's see, I'm going to have my ground coming into the light-dependent resistor on that end. And then I'm also going to take from that ground, I need to take something out of there someplace else, which is going to be to the Arduino controller. And then I have my input over here. I think it's really important. Some people don't worry about it. I think it's really important to color code what you're doing to make sure you're using the red and black wires appropriately. Even so, I still have to keep track of inputs and outputs. Where am I attaching the battery and so forth. Now, I've twisted this together, which is essentially what I did when we were making the Tadro. There's a little slicker way to work with your circuit for starters, and it's called a breadboard. And it's a solderless breadboard, and that's this thing right here. And I've already got this wired up. Here's our Arduino microcontroller, which we love. I've got this hooked up with a servo. So I've taken apart, I've gutted a Tadro. I've got my power supply and USB connector into that power supply. Let me explain really briefly how a breadboard works. So this thing has outer power strips that are connected internally so that if I bring in power through this cable here, this wire, it electrifies this whole column. Likewise, anything I put in this second column will also be electrified together, connected in a circuit. What happens in the inside here is it's actually the rows that are automatically connected. So if we do something like I've done here, which is, here's our light-dependent photoresistor, which I just twisted together, you can see I've connected it up to here in this circuit a positive line. Okay, so by virtue of putting them in the same row, they're actually connected. And I can test that. Now I'm going to get rid of those clips, go back to continuity here, and I can test that continuity by touching, let me bring this out of the way here, by going in and touching that leg right there, so that's continuity, but now I'm going to touch it with that wire. So you can see that proves to you, right, that that row is actually connected. That's the magic of a solderless breadboard like that you don't have to do any wire twisting, and it's a way to lay out your circuit and make sure it works before you do something like solder it together. So what I've got here is, on the Arduino side of things, I'm taking advantage of the fact that Arduino will output 5 volts. So this red wire is taking 5 volts out of Arduino and delivering it to this breadboard. That 5 volts, which is all along that column, is being sampled or used by this part of our voltage divider, which is our light-dependent resistor, which goes and connects, we had twisted those together with the fixed resistor. They have a common linkage with another red wire here, which is actually going to the AO, or the analog input channel 0 on the Arduino. So instead of measuring that voltage split with a multimeter, we're measuring it with Arduino. And Arduino is going to use the change that happens when this variable resistance takes place to connect up changes in light to a change of instructions for the motor. Okay? So here's our ground that goes directly here. Now, I've got a beautiful little servo motor here, and I've hooked up a flag so we can keep track of what's happening when I turn this on. Servos, remember, are DC motor with potentiometer. The control line is in yellow, so I've kept that yellow here. I've done all these wires in solid core because with solid core I can punch them into that breadboard. The stranded core wire won't work. So I've got this coming out of PWM, which is pulse width modulated lane here, and into the PWM line of the servo motor. And then I'm powering the servo motor from this strip that we're electrifying, and I've got it connected to ground. So if I've done this right, and I think what I've got here is an interesting difference. I had put this resistor in the wrong place when I twisted them together, and I can tell that right away by the color coding, and you may have picked that up earlier. So what would happen is, instead of being light seeking, our Tadro would have been light averse if I'd put that resistor in the wrong place. And by the way, that's a way to get different behavior out of it, by redoing your circuit. All right, this is a USB power supply, and I'm very carefully tangling up the wires here. So I'm going to plug it in this way here, and then plug it into Arduino. Now you can actually use a 9-volt battery to power your Arduino, which is what we do in our Tadro. But I just find it easier at this point to use one of these USB power supplies. Plug it in, and guess what? I have the Tadro program loaded on this Arduino. I don't know if you saw the servo jumped there when I turned it on. So there it's just sweeping back and forth like it's moving the tail, as you can see here. Now we're going to do our thing of changing, put a little shadow on the photoresistor. Oh, do you see what happened? It just jumped. Remove the finger. So that's that connection between what's happening in the world through a sensor and a controller telling the motor to respond. So acting and reacting. Very cool. So this is the guts of a Tadro here, and we've put our circuit on a breadboard, which really helps us understand what's happening with the flow of current out of 5 volts here onto that strip, through that resistor, so you get a drop of current here, which we pick up through our voltage divider, and you've seen how that works. So we're measuring that drop in, voltage through that resistor. Once again, okay, we see that jump. Awesome. So that's the nitty-gritty there of our Tadro. I'm going to put this all back into a little bin, keep ourselves organized, our workspace clean, and now let's move on to another circuit over here, which is very useful for hacking. And when I say hacking, I mean like getting into toys and turning toys into a robot. So I've got here, you can recognize a breadboard, a DC motor hooked up, and I've got what we call, I didn't give these wires name jumper wires because they jump from one place to another. From a black terminal to a red terminal, I'm now electrifying both lanes here. I didn't electrify the ground lane in our previous breadboard. This breadboard's a little more extensive because it's got these poles here that I can connect up a power supply to. Let's just see what happens here, and then I'll explain the circuit on the breadboard. There we go. So we have that working, and what's going on here? Well, we have a photoresistor in this circuit, so it's always tempting. Ooh, sensor! What's going on? We'll put it in shadow. Look what happens to that DC motor. Can't even hear it vibrating now. It's slowed way down. Well, this is cool. I mean, it's kind of the same thing that was happening with the Tadro circuit. I'm going to release my hand. Look at that. But something else is going on here, right? There's no Arduino. So we've made a circuit here that's sensitive to light, changes what a motor is doing without having a microcontroller in here. That's why this circuit is useful for hacking. So we don't have to put a computer into whatever we're hacking. Now I'm going to use my locking forceps again to talk a little bit about this circuit. So we have these lines electrified. You can see little jumpers over here that are coming in and doing a kind of voltage divider thing. But there's a new circuit in here, and I'm actually going to pull this motor out so we get a better view of what's going on here. There's a fixed resistor, motor, and our light-dependent resistor, which you've already met. But what is this thing right here? It's a transistor. A transistor is can be a fancy kind of switch. And what a transistor does is it's sensitive to the voltage that is being divided by that voltage divider that we've put in there. And what it actually does is it's a kind of gate that allows greater amount of current to pass through it to power the motor. So the problem is if we just put a voltage divider in series here with the motor, we wouldn't allow enough current to pass to actually drive that motor. So we've got to use that transistor as a sort of gate to allow us to use a little bit of current change to sort of prime the pump in on a parallel track in our circuit, allow there to be enough current through that motor. All right, very cool stuff. I'm going to put this to the side here, to the circuit, and now I'm going to show you that circuit in a hack. This is a very common thing that we like to use in robots called a tank track. This was actually a kit that you can buy and you build it, and it's meant to be the basis of any kind of robot you might want to do. I've already built it, and then actually Peter Staten built it for me, a student who works in my lab. And then I cut the wires that he carefully put together. You can also get any sort of toy that just goes straight when you turn it on. So I've got those wires twisted together so you can see our tank track work. Let's see if we can get it to climb up. Great thing about tracks, right, is they get up and over stuff here. And there's a switch that allows you to change direction. All right, so that's what it does, but it's blind. It's not an interesting robot. There's no sensor attached. So we've got actuators, we've got a body, but we have no sensors. So here's where our hack comes into play. Now, remember, it doesn't have to be pretty, and I'm showing you, it doesn't have to be pretty. Here's the circuit that we had beautifully laid out on the breadboard. Here's our transistor to allow us to hack this and make it into a robot. Okay, so I've labeled, so I don't forget, I've got motor plus. So I'm looking back here and I've labeled these wires too. It turns out with a DC motor, you can actually run the current through it either direction and it will work. So for the moment anyway, this doesn't matter. I'm just doing the quick and dirty twisting together. Let's see if I'm actually capable of doing it. Okay, twist, and have to be careful to get the motor and not the power supply here. So that's the motor positive. Black means negative, so I'm looking for, I've labeled it motor negative. Okay, this way I don't have to constantly be looking to try to see the circuit that I've got going. And then we have the battery. Okay, so we have the negative battery right here, and I've got the negative labeled as black. So in 2 shakes of a lamb's tail, we're going to have a photosensitive robot here. Okay, now what I'm going to do is actually put it up on top of this piece of tape just so that it doesn't run away from me here and run off the table. Okay, let's see. Got it working. Oop. Okay, great. Working. Oop. Get those wires together. Working. So you can see as I put my hand over it, the motor slows down. Perfect. It's working great. That's excellent. We have a super system. Let me just turn it off here. So what we've created is a light-sensitive robot. Awesome. Now, one of the great things about hacking a robot is that anybody can do it. And another thing that any of us can do is build a robot from a kit. Here's a kit from Vex Robotics to build Clawbot. Clawbot is a great way to get started on building a sophisticated robot, in this case one that includes a manipulator and a mobile robot base. So best of all, when you start building robots like this and getting them to work, you know what? You're getting a shortcut to creating life. I know, it's not life exactly, but it's something lifelike and just as interesting: autonomous robot behavior.